Hey, so I learned something cool today about how ETC uses ACN to send DMX over a network. So what you're looking at here is a little spotlight level display that I'm working on. This is for a company that uses ACN controlled dimmers to drive their spotlights, but they still want to give their spot ops a local level display of what level their spot is at. So all this is doing is the Arduino is listening for ACN packets to come over the network. It's checking that they're in a specific universe and a specific address. In this case, universe 1, address 118. And then it's slurping that address in and displaying it as a percentage on the screen. So at the moment, the TI over here should be sending out a level of 0 at universe 1, address 118. But you can see it's flickering back and forth between 0 and 39. Which is very strange. And I chased my tail on this for a while. I thought originally maybe it was something to do with the way that we handle ACN priority in our space, because we do have a paradigm system over there on the wall, and I thought, since we are changing priority levels in some of our presets, maybe it was something to do with that. But it turned out not to be that. I thought maybe it was to do with the ACN library I was using. Maybe there was a buffer not being cleared. Maybe there was something in the way it was handling HTTP that was not correct. But it turns out to not exactly be that either. I only figured it out when I started looking at the actual ACN packets themselves in Wireshark. So here's an example packet of ACN. It's coming out from my TI address 10.101.92.101, and it's in universe 1. It's at 239.255.0.1, which is the multicast address for ACN Universe 1. And then here's the actual contents of that packet. So one thing I did just to make this a little easier is I parked address 1 at full, and I parked address 2 at 50%, which in this case are hexadecimal FF and 80, just to make it really easy to find the start of that data. And I also parked address 100 at full, just as a marker, which means that the data I'm interested in, address 118, should be right here. And we can see that as intended, it's at 0 in this particular ACN packet. But let me click through a few other packets. You can see these are all identical until we get to this one, which is super interesting. So now we have address 1 went to hexadecimal 64, address 2 went to 64, address 100 went to 64, and address 118 went to 64. Super interesting. What's going on here? Well, hexadecimal 64 out of FF, out of a possible 255, is about 39%. So is this our smoking gun? Well, yes, it is, because if we look at the other things that change in this packet, I'm going to click back and forth between this, what I'm calling a bad packet, and a good packet. So if I click back and forth, what are the actual pieces of this packet that change, right? So you'll see there's a couple things that change. You'll see this value right here go from C3 to C4. But all that is a sequence number, right? That's just going to count up by 1 for each sequential packets, and that's not super interesting. We also have this value right here, which is also hex 64. And it's worth saying that hexadecimal 64 is decimal 100. And that is actually the priority level of this ACN packet. So the ACN is coming out of the TI at priority 100, that setting that you set in the EOS shell of what priority your ACN should be that's encoded into each packet right there at 64. And the other thing that's changing is this value right here in the bad packet, which is DD. In a good packet, right before I started the data there, you see it's 00, but in this packet, it's DD. Now that is the DMX start code, and it immediately precedes the start of the DMX data. In a typical data packet, that start code is 00, or the null start code. That says, interpret this as straight up DMX data. But when that code is DD, we have to refer to the table of alternate start codes, which is maintained by ESTA as a part of ANSI E 1.11. and they maintain a full chart of what these codes are. And this is meant for manufacturers to be able to transmit their own proprietary or open data, whatever they choose, in something that looks like an ACN packet. And so you can see right up here at the top, hex 00, registered to USITT, the default null start code, that's DMX data. But then you have all these other companies that have registered themselves with individual start codes. You have 088, you have artistic license, sending I haven't read through all this. I don't know what all these things will do. But if we scroll ahead down to the last page here, we'll see start code DD, registered to ETC. Alternate start code DT is for use in transmitting per channel priority for use in merging streams and multi-source DMX applications. Priorities are ranged from 0 at the low end, which means do not use the data in the corresponding slot, to 200, which means this data over any slot data supply with priority between 0 and 199. Values above 200 are reserved. So what that bad packet is doing, if we click back over here to Wireshark, it's essentially saying it's not a bad packet at all. It's just doing something different from a regular DMX packet, right? So in our regular packet, the values that follow here, that's all DMX data. But ETC is allowing themselves to send this alternate packet with start code DD, which is saying, hey, sorry, I'm bringing it back there. Boop, boop, where are you? There we go, DD. Which is saying, hey, this is going to be one of those ETC priority packets. And hexadecimal 64, we said, is decimal 100. So this is saying, I have data for this address at priority 100. I have data for address 2 at priority 100. I don't have any interesting data for address 3 or address 4 or any of these other data. If you are in a situation, if you are a system that understands what this packet is, if you are an ETC product or another product that understands what a DD start code means, you can ignore any DMX data that you see from me in these addresses. So you're really only listening to address 1, 2, 100, and 118, all at priority 100. So let's wrap it all up. So this is address 118 with a hexadecimal value of 64, which we said is decimal 100, or about 39% out of 255. So what's happening is that there is not a problem, but a funny little thing about the ACN library that I'm using. It's seeing this packet. It's not checking the start code. It's just happily interpreting all this data. And it's when it gets to address 118, it says, oh, for this one packet, for some reason, I have data at hexadecimal 64 at 39%. I'll gladly put that on the screen. And then the very next packet takes us back to our hex level of 0, and I'll put that on the screen. In any case, super interesting thing I didn't know about ACN and ETC's use of this alternate start code to encode priority per address priority into alternate ACN packets. Super cool.